Oh, what's going on? Got another video here for you, solving differential equations, and this is solutions by substitution. All right, well, let's get started. All right, so we've got, suppose we have to transform the first order differential equation dy dx equal f of xy by the substitution y equals g of xu, where u is regarded as a function of the variable x. If g possesses a first partial derivative, then the chain rule dy dx is the derivative of g, and these are all actually written incorrectly. It should be the partial of g with respect to x dx plus the partial of g with respect to u du dx. Must have got in a hurry when I was writing that up. I mean, I've got the partials over here, but okay. Which that gives dy dx as the partial of g of xu with respect to x plus the partial of g with respect to u du dx. All right. So that's just the chain rule. You've done that before. All right. So if we replace dy dx by the foregoing derivative and replace y and f of xy by g of xu, then the differential equation dy dx equals f of xy, the differential equation we started with up here, our original one, becomes this: the partial of g with respect to x plus the partial of g with respect to u du dx equals f of x g of xu, which, solved for du dx, has the form du dx equals f of xu. Okay, all this might not make a lot of sense to you, but we'll explain that in more detail when we go through the example. If we can determine a solution u equals phi of x of this last equation, this equation right here, then a solution of the original differential equation is y equals g of x phi of x. All right, and then we've got homogeneous equations. If a function f possesses the property f of tx ty equals t to the alpha times f of xy for some real number alpha, then f is said to be a homogeneous function of degree alpha. And here's a couple examples. So we've got f of xy equals x cubed plus y cubed. So basically what we're doing is we're taking f of xt yt is equal to xt cubed plus yt cubed. We're just plugging the xt and the yt in for x and y. And so this is going to give us x cubed t cubed plus y cubed t cubed. And then you can see here we can factor out a t cubed. Let me write that 3 a little bit better. And then that's going to be times x cubed plus y cubed. And so you can see this is t cubed times f of xy. All right, and see the x cubed plus y cubed is f of xy. And see we have it, it's in this form here, t to the alpha. In this case, alpha is 3. So this is a homogeneous function. But now this one is not. If you take f of xt yt is equal to xt cubed plus yt cubed plus 1, that's going to be x cubed t cubed plus y cubed t cubed plus 1. So you can't, there's nothing you can factor out there. So that's not a homogeneous function. Okay. All right, so it says a first order differential equation in differential form, mxy dx plus n of xy dy equals 0, is said to be homogeneous if both coefficient functions m and n are homogeneous functions of the same degree. All right, so we just showed how to determine if it's a homogeneous function here. All right, and then basically if you have a differential equation in this form, if this and this are both homogeneous functions of the same degree, okay, which is this, okay, if they're both homogeneous and they're both t to the alpha, and of course alpha is the same, if m and n are homogeneous functions of degree alpha, we can also write m of xy is x to the alpha m of 1u, and n of xy is x to the alpha n of 1u, where u is y over x, okay, and it's the same thing here. If m of xy is equal to y to the alpha m of v1, and n of xy equals y to the alpha n of v1, where v is x over y. Okay, so what does that mean? Well, the above properties suggest the substitutions that can be used to solve a homogeneous differential equation. We can do y equals ux, or x equals v times y. You can do either one. Okay, you can use this substitution or you can use this substitution. Okay, so which one do you use? Well, it doesn't matter, but it may make a difference, because if you use this one and you come across something and you say, oh man, that's going to be really difficult to integrate, or impossible to integrate, then you may not want to use this one. You may want to try, erase what you did with this and come up here and let x equal by. Okay, just try one. If it's difficult, you don't like it, then do the other substitution, where u and v are new independent variables. We'll reduce a homogeneous equation to a separable first order differential equation. So basically what we're doing is we're making a substitution, and it's going to reduce it to a separable first order differential equation. So with all that being said, let's go ahead and look at an example. So we want to solve this. Okay. All right, and we're going to solve it using substitution. So we've got to see if this is homogeneous and this one. All right. So we've got m of xy is equal to x squared plus y squared. All right. And so that's going to give us m of xt yt is equal to x squared t squared. If I plug the xt in for x, I'm squaring it, so I'm going to get that, plus, and then we plug this in for y, that's going to be y squared t squared, which is equal to t squared times x squared plus y squared, which is t squared times m of xy. And then we have n of xy is equal to x squared minus xy. And so n of xt yt is equal to x squared t squared minus, okay, now we're going to plug this in for y. Plugging this in for y and this in for x. So that's minus xt times yt, which is x squared t squared minus xy t squared, which that's going to give us t squared times x squared minus xy, which that's equal to t squared times n of x, y. So they're homogeneous and they have the same degree. All right. So that means we can make a substitution. All right. So what I'm going to do is I'm going to erase all this so I don't run out of room. All right. So what we're going to do here is we're going to make the substitution. We're going to let u equal, no, not u. You got my mind on u sub. Let y equals u times x. Okay. So then we have dy is the first function times the derivative of the second plus the second function times derivative of the first. Okay, so there's dy. And so what we're going to do now is we're going to plug everything in. We're going to plug this in for y and this in for dy. So I've got x squared plus ux squared dx plus x squared minus x times ux, oops, dy. See, it's got the dy here, but what are we putting in the place of dy? This. So that's going to be times u dx plus x du. And that equals 0. All right, so this is going to give us x squared plus u squared x squared dx plus x squared minus ux squared times u dx plus x du equals 0. All right. All right, so now what we need to do is see about simplifying this thing. So let's go ahead and start simplifying. So let's see what we've got here. How can we do this? Let's see, we can do x squared plus u squared x squared dx plus, now let's go ahead and multiply this out. So that's going to be ux squared dx plus x cubed du minus u squared x squared dx minus ux cubed du equals 0. All right, so let's go ahead and group these terms together. So I can write this x squared plus u squared x squared plus ux squared minus u squared x squared, all right, dx. So basically what I did, you see the dx, and the dx here. So I just took this term, and this term, and just kind of wrote them here and factored out a dx. All right, and then we have, let's see, where is it? We've got a du and a du. So we can write this as plus x cubed minus ux cubed times du equals 0. All right. And so what we have here is, let's see, look at there. That term and that term's going to cancel out. So that's actually going to give me, well, let's write it like this. X squared times 1 plus u dx. See, I just factored out a common factor of x squared. That leaves me with 1 plus u. All right, and then that's going to be plus, and then that's going to be x cubed times 1 minus u du equals 0. So basically, I mean, think about it. What are we trying to do? Separable equations. So we want to get all the u terms with du and all the x terms with dx. So what I'm going to do here is, you can see this 1 minus u is already with the du. That x squared is with that dx. So what I'm going to do here is I'm going to multiply by 1 over, multiply or divide through by, it's, you know, it's the same thing. X cubed times 1 plus u. That's what I'm going to multiply each term by. And so what that's going to give me is, that's going to give me 1 minus u du plus, I mean, and it doesn't really matter what order you write it in. Well, let's see, let's write it. That's going to give me 1 minus u over 1 plus u du. Okay. See, well, let's do this. Whoops. I didn't want to do that. Let's do this. Let's write it in a different color. Maybe it might be easier to see like this. Let's do this. And we're going to do x cubed times 1 plus u. X cubed times 1 plus u. That's easier to see, isn't it? All right, so the x cubes are going to cancel. So that's 1 minus u over 1 plus u du. And then here, these are going to cancel. And then I'll be left with the x down in the denominator plus 1 over x dx equals 0. All right. All right, so now how do we need to go about solving this thing? Well, we can integrate each term, right? We can integrate each term. See how much room I got. I might have enough. All right, so, well, integrating that, well, let's do this. Let's do, come over here to the side, u plus 1, and then negative u plus 1. I'm going to do long division. All right, make this thing over here easier to integrate. All right, so remember, this is going to be u times negative 1. Let me go back to that other color. U times negative 1 is negative u, so that we're going to that's negative 1. So then we multiply negative u minus 1, and then we change the signs and add, so that's 2. And so this divided by this becomes negative 1 plus 2 over u plus 1. Okay, so this is going to be negative 1 plus 2 over u plus 1. All right, du plus 1 over x dx equals 0. All right, so now what we're going to do is we're going to integrate everything. Okay, we're going to integrate everything. So, of course, this is going to be what? Negative u plus 2 natural log of 1 plus u. Okay. And, you know, I guess if you wanted to, you could write u plus 1, 1 plus u. Doesn't really matter. Plus, and then this is going to be natural log absolute value of x equals, and then when we integrate 0, we get a constant c. Okay, we get that constant c. But what I'm going to do is I'm going to write this constant as natural log c because of this. I've got these natural logs here, May make it a little easier. Okay. And so now let's do some substitution. Okay. So you see the u right here. Okay. So I've got to plug back in. I got to get everything back in terms of x and y. And let's see. What does u equal? See, look at this. I'm plugging in for u. Well, remember the substitution we made here, y equals u times x. So that tells me u is equal to y over x, right? U is y over x. And so I've got negative y over x plus, now for this one, let's write this as natural log of 1 plus y over x. See, in the place of u, I'm putting y over x and moving the 2 up. That's squared. And then plus natural log absolute value of x minus natural log c equals 0. So what I did there is I just moved everything over to one side. And so now I can rewrite this as negative y over x plus, and that's going to be the natural log. Okay, so that's going to be the natural log of what? Well, that's going to be x times 1 plus y over x squared over c equals 0. I'm just using my logarithmic properties to combine it as a single log. Now let's do something with this in here. Okay, so remember we've got, well, I'm gonna just come over here to the side and do this. 1 plus y over x. All right, so I can get a common denominator of x, so that's x, y, so that's x plus y over x. Okay, and remember this is squared, right? See how that's squared? So I can actually write this as x plus y squared over x squared. All right, so this is minus y over x plus natural log of x times x plus y squared over x squared, and that's over c equals 0. All right. And so look what happens here. That and that cancel. I'm left with an x. So I get negative y over x plus natural log absolute value x plus y squared. Whoops. X plus y squared over cx equals 0. And so, I mean, as far as your answer goes, how do you write it? I mean, I guess if we wanted to, we could bring this to the other side, and that would give us y over x is equal to natural log of x plus y squared over cx. All right. Or we could write e raised to the yx equals x plus y squared over cx. So that would give us x plus y squared is equal to cx e to the y over x. Okay, so I mean, I guess, you know, you could maybe leave it like this, or you could go on and write it like that. You know, whatever your teacher tells you to do, do that. All right. So, you know, it's not bad. I mean, it gets kind of messy in here, right in here, having to do all that simplification, but, you know, in the end, it's not too bad. All right. So now let's look at this one. Bernoulli's equation. The differential equation, dy dx plus p of x times y equals f of x, and then see here we got this y to the n, where n is any real number, is called Bernoulli's equation. Note that for n equals 0 and n equals 1, the equation is linear. For n not equal to 0 and n not equal to 1, so this exponent here is not 0 or 1, the substitution u equals y to the 1 minus u, not u, I don't know, we're getting all these x's and y's and u's and everything. 1 minus n, u to the u equals y to the 1 minus n reduces any equation of the above form to a linear equation. All right, so let's see how we're going to go about solving this thing. All right, so let's go ahead. Let's go ahead and get this in this form here. So we're going to divide everything by x. So when we do that, we're going to get dy dx plus 1 over xy equals xy squared. All right. Now notice here our n, that's the exponent here on y, n is equal to 2, and we have u is equal to y to the negative 1. Well, remember 1 minus n, so u is equal to y to the negative 1. Or we could write y is equal to u to the negative 1. Okay? All right, so now what do we have here? We've got dy dx is equal to dy du times du dx. All right, so we've got dy du, derivative of y with respect to u, that's going to be negative u to the negative 2, we're taking derivative of this thing, and then times du dx. All right. All right, so now let's make our substitutions. So this is going to give me negative u to the negative 2 du dx plus 1 over x u to the negative 1 equals x u to the negative 1 squared. So all I did is I took, you see here dy dx is this thing, I just plugged that into there. And then the u to the negative 1, I plugged that in for the y terms. And so, I mean, of course we know this will just be u to the negative 2. Okay. All right, so what we can do here is we could solve this using what? Using integrating factor. So I need to, what do I need to do? Divide everything. I'm going to divide everything by negative u to the negative 2. All right, so this is going to give me du dx plus 1 over x, no, not plus, minus, the minus and the plus make a minus, and then over here, remember, that's u to the negative 1 minus negative 2, which is just u to the first power. Okay, and so that would be u equals x. All right. Now, whoops, and that's a negative there. I overlooked the negative. That should be negative x. All right, so now let's get our integrating factor. So we know that in this case, we've got p of x is negative 1 over x. So our integrating factor is e to the negative integral 1 over x dx, which is e to the negative natural log x, which is equal to e to the natural log x to the negative 1, which is just equal to x to the negative 1. And we're going to look at this on 0 to infinity. Okay, we don't have to worry about absolute value. We know it's going to be x is going to be positive. All right. And so now, remember, what do? We take our integrating factor and multiply it to each term, right? So that's going to be x to the negative 1 times du dx minus x to the negative 1 times 1 over x u equals negative x times x to the negative 1. And so, what did we do? All right. And so now I get what? I get du dx, the derivative of x to the negative 1 u. Remember, for integrating factor, whenever you multiply both sides by the integrating factor, the left-hand side becomes what? The product of the integrating factor and your variable. Typically it's y, but in this case we have a u. Okay? And that equals negative 1. And then we're going to integrate both sides. We got du dx, x to the negative 1 u dx equals the integral negative 1 dx. All right, so that's going to give us x to the negative 1 u is equal to negative x plus what? Plus our constant c, plus c. And so now we get u is equal to, so for this, I'm going to divide everything by x to the negative 1. So let's just write that out. All right, so remember, x over x to the negative 1 is x to the 1 minus negative 1, which is x squared. So u equals negative x squared plus cx. But we got to get, we're solving for y, right? So what was u? U is what? Let's go back up here and look. Right here. U is y to the negative 1, or we can say u is 1 over y, right? Oops. So I've got 1 over y equals negative x squared plus cx, or I can say y is equal to negative 1 over x squared plus cx. And there's your answer. Whoops, no. I can't put that negative out there. I mean, I could put the negative out, but I don't think that would be, but we would have to write it like that if we put the negative out there. So we just leave the negative there with the x squared. All right, so that's not too bad. All right, now let's look at this, reduction to separation of variables. A differential equation of the form dy dx is equal to f of ax plus by plus c can always be reduced to an equation with separable variables by means of the substitution u equals a of ax plus by plus c, where b is not equal to 0. All right. So let's look at this one. All right. So here we are going to let u equal negative 2x plus y. Okay, this part right here inside the parentheses. And so that tells me that du dx is equal to negative 2. Okay, and then this would be what? This would be dy dx, derivative of y with respect to x. All right, so now let's see what we get. Whoops. That should be plus dy dx. I forgot to put my plus sign in there. So let's do our substitutions. So you can see that this means that dy dx is equal to du dx plus 2, right? So this I'm going to put in the place of dy dx. So I've got du dx plus 2 is equal to u squared minus 7. And so that's going to give me du dx is equal to u squared minus 9. All right, so we can do separation of variables. So that means I'm going to get du over u squared minus 9 is equal to dx. So we can integrate this. So to integrate that, well, we're going to need to do what? Partial fractions. Let's come over here to the side. I did this in an earlier video with a problem similar to this, but I'll go ahead and do it again. So let's see if we can squeeze it right in here. So I've got 1 over u minus 3 times u plus 3 is equal to a over u minus 3 plus b over u plus 3. Multiply 1 equals a times u plus 3 plus b times u minus 3. So we'll let u equal negative 3, so that goes to 0. This is going to be 1 equals negative 6b, so b is equal to negative 1/6. And then u equal 3, so that's going to go out, so I get 1 equals 6a, so a is equal to 1/6. All right, so basically what we have here is we have 1/6 over u minus 3 minus 1/6 over u plus 3, which I can write like this, times 1 over u minus 3 minus 1 over u plus 3. I just factor out the 1/6. So all of this, okay, all of this can be written as 1/6 times 1 over u minus 3, minus 1 over u plus 3 du equals dx. All right, so now let's integrate. So this is going to be 1/6 times the natural log of u minus 3 minus natural log of u plus 3 equals, and that's just going to be x plus, and let's write this. I mean, we can write it as c. We might change it later, but let's go ahead and write this as c1. I mean, let's see, we've got 1/6 natural log, absolute value u minus 3 over u plus 3 is equal to x plus c1. And so I get natural log of u minus 3 over u plus 3 equals 6x plus 6c1. And so let's get rid of the natural log. So that's going to be u minus 3 over u plus 3 equals e to the 6x plus 6c1. I just did put the e as the base on both of those. All right. And so now I've got u minus 3 over u plus 3 is equal to e to the 6x times e to the 6c1. And so u minus 3 over u plus 3 is equal to c e to the 6x. And so what I did here is I said, okay, c is equal to 6c1. All right. Whoops. No. Is e 6 to the c1. Forgot the e there. All right. All these substitutions, man, I tell you, got to be careful. They'll mess you up. And so now let's go ahead and multiply. So I get u minus 3 equals cu e to the 6x plus 3c e to the 6x. And just multiplied this, see u plus 3, and I just distributed. And so what do we want to do here? Okay, so let's write this as let's write this as u minus c u e to the 6x equals 3 plus 3c e to the 6x. Just get everything with the u on one side. And so that's going to give me u times 1 minus c u e to the 6x equals 3 times 1 plus c e to the 6x. And then divide both sides. U equals 3 times 1 plus c e to the 6x over 1 minus c u e to the 6x. All right, so we're getting there. It's looking pretty good. But, of course, u is the variable we used for the substitution. So what was u? So where is it? We let u equal negative 2x plus y. So that gives me negative 2x plus y, plus y equals 3 times 1 plus c e to the 6x over 1 minus c u e. Wait a minute. What in the world did I do? Nah, why did I put a u there? C e to the 6x. What the u? I'm sitting there. There we go. That's better, isn't it? All right. I'm losing it. All right. So now that's going to give us y is equal to 2x plus, and that's going to be 3 times 1 plus c e to the 6x over 1 minus c e to the 6x. But I don't know if you remember this or not, but up here in the problem, we have y of 0 equals 0. So we can solve for c. We're going to use y 0 equals 0. So that's going to give me 0 equals 2 times 0 plus 3 times 1 plus c e to the 6 times 0 over 1 minus c e to the 6 times 0. And so that's going to give me 0 equals, let's see, what is that going to be? 3 times 1 plus c over 1 minus c. Okay. And so let's see, how are we going to go about solving this? Well, this is going to give me 0 equals, well, we know that a fraction is 0 when the numerator is 0, right? So 1 plus c, divide everything by 3, c equals negative 1. And so that will give us our solution. Y equals 2x plus 3 times 1 minus e to the 6x over 1 plus c, no, or 1 plus e to the 6x. And there is your solution. All right. So, I mean, you just gotta slow down, take your time. You can see I had a few screw ups. I caught them though, but you know, I mean, all this substituting in back and forth and variables changing. You just gotta slow down, take your time, and pay attention to what you're doing, basically. All right. Well, I hope you enjoyed that video. I hope it helped. Check out my other videos. Give me a like, share, subscribe, comment, and I will see y'all in the next one. Later.